Hi everyone. Welcome back to my lessons on image creation, specifically my PFTF project called Pretty Pictures, the importance of visually stunning images in research. And so today, the second lesson of this series is talking about technicalities of image. So we're going to deconstruct some of these technical aspects of image creation. So this could be a little bit scary for some folks at the beginning, especially when the popularity of image taking and image processing has been always a professional job for folks, and so this is a little bit difficult to do. So I think that after this session, you should be able to take away some good learning. Um, uh, you should take away some good learning about the specifics of technicalities that images are used. And so if we jump into learning objectives, we're gonna participants will be able to distinguish between what a raster image is and what a vector image is. They should be able to examine some differences as well between high quality and low quality images. And we will define that more in detail. And then hopefully by the end you'll be able to know which specific type of images you would want to use for certain use cases. So jumping right in, so we're very familiar with using images today, but we're going to talk a little bit about how images are taken in our own world, but also how you're interacting with images for the most part, which is through a handheld camera device. And so initially, what happens is that you see something in nature, you're taking an image right now of me, maybe you go outside, you take a picture of a tree, and so you have this sensor array, which is essentially somewhere inside of this very, very complicated high-tech device. And so that essentially absorbs a bunch of light into kind of this array of different colors. And so essentially imagine this being the sensor array. You have a bunch of colors that are essentially figuring out what color they should be based on the light that they see. And so this is like a discrete image of something, and this is probably some text here, and these are individual pixels. But you can imagine the array being measuring every single one of these light images from some aspect of nature, maybe a monitor in this case. And so once it takes the real image, it maps it onto some digital image. And now, once you have that, we need to convey that image to somebody, right? So we need to share that image. Typically, we send it to text message now through a phone, but before we would convert it into some JPEG image file, which we'll discuss a bit more later. But essentially, it maps this image into a set of pixels, and so this is a bunch of pixels that then have individual colors. And so we're not going to talk about the details of coloring schemes because there's different coloring schemes for different media, but essentially here it's essentially taking every single one of these pixels with individual color, and the screen dictates what type of color it will be based on the percentage of red, green, and blue. So if we think of our color wheel back when we were in grade school, this is what this is doing. Red overlaid with green overlaid with blue at this percentage gives us this shade of grayish white, whereas yellow is red and green overlaid at 90% is that type of yellow that we see here. And so this is how we interact with images, but this is a little bit about how they were created. But now we talk about these digital images for our creation processes. We have to talk a little bit more into the type of images that we save. So this image that is saved on a computer, which came from some image rendering at some point, will have to be discussed. So let's start with the picture that we described earlier, which is you just go out into nature, as here. This is on one of my recent trips to Japan, and so I took a picture here of the famous crossing, some building image. It was a bunch of folks down there. And so this is what's called the raster image, meaning that the sensor took an individual light measurement for this area here, and then essentially measured what it is. And so this is what a raster image would be. There's raster images that don't look like this, which are illustrations as well. But this is a raster image that we traditionally call. So this is things that are set in finite, that are set in a finite resolution. Every single one of these colors here is a mapping from the image that I took. So this is a raster image. And the important thing about raster images is that you cannot stretch them infinitely. And so we'll talk about that in quality, but all the information contained in this image is here. And the quality, which we used to describe with pixels or megapixels back when they were point and shoot cameras, or they're still with our iPhone, the resolution of that image is what is called a raster image. And so here is a depiction of the pixels that we see on a raster image. So this again is also a raster image, but in here, this is what we're describing as a collection of individual files. And so as we zoom in, we see the individual actual pixels, and we do not actually have more information that is stored in this raster image. So this is a purely rastered image, and we zoom in, these are the pixels. There's no more information that is created in there. Alternatively, to a opposite of what a raster image is a vector image. And so this right here is a vector image, and it's very small. It's just a circle and an ellipse, different colors, and so there's a simplicity in this vector image. So vector images are described by the position in space with a certain set of either proprietary or open source directives. And so the quality of the vector images is, one of the benefits of a vector image is that it's infinitely resizable. So what does that mean? So I can take that image and resize it. So this is what I did here, and it looks still pretty good quality. I don't think that it's lost too much of the quality. And if I want to zoom a little bit more again to make it much bigger, the quality is maintained because this image is not defined by where individual pixels on a final raster image, but it's a set of commands that create this circle and this ellipse. So what makes a vector image so powerful? Well, maybe we might want to go inside and see inside this matrix or see inside of the vector image and see what makes it so powerful. So let's take a peek of what's inside a vector image. So here is the actual definition of this scalable vector graphic, or an SVG, and I call this this is just a sample. And so it's a text editor, and I open this image with just a simple text editor. So you can take your text editor that you have to create text. Maybe not Microsoft Word, but you should probably take your text editor and open it up. And what you see here is a bunch of things that talk about standards, and this is actually defining the image. And so down here, what we see is the height and width of the image, as well as the view box, some other information, the program that it was created with, and so this is actually the vector image that we just described. But if we look at the actual definition of the circle and the ellipse, we see here the color that it's defined and the fill. And so this is the location of where it is as well as its fill. And so this describes it exactly what the color is. So essentially here you can change this color and it would change to a different color. And so this is a little bit hard to read because you would need to know what the SVG syntax is for the color. But essentially this right here, changing that changes the color. This is a hex value for a color inside a vector image. But as you can see, this here is what's describing our actual vector image. And we're not going to create vector images using text files, although if you wanted to, you could do that. Obviously, we'll use tools to create this. But as you can see, all the information for the vector image is encapsulated within this file, and we can make it infinitely large. And so now we have to talk about quality of images, because when we make vector images, sometimes we have to convert them to raster images. And for example, in this case, on the right hand side is a vector image that I created with a program that I will describe later. And on the right hand side is the same image once I outputted it to a specific file format called a PNG with a low resolution. And so you see this, we've lost a little bit of resolution here. The right one looks more crisp. The edges are defined better, whereas the edges on this side are defined a little bit more loosely. And so if I zoom in a little bit more, we can see that in this specific image, the original pixel width and height is this. And so here is the higher quality image. When the pixel height is reduced, that means that there is some blending of the image. As you can see, this is beginning to a little bit blurry. And if we make the image a lot smaller, there's a lot more blurring. And so this might affect some of the quality of your image that you can get. Image quality is a very important thing to consider. So what technicality should you use? This is the recommendation. This is what we are all trying to understand. This is what we want to discuss. And so you can create a drawing using a tablet, and that usually will save that to a raster image, although there are programs that now create vector images. So creating a tablet is a good alternative. You can create an illustration with the graphics program, and this is the goal of all our lessons, to teach you how to create illustrations. Or alternatively, you could just do a pen and paper drawing, and we will do the majority of these techniques in our tutorials, but this is giving you kind of an outline of really use them whichever way you want them to, as long as you have the information that you want to encapsulate into that image that you have been thinking about. So hopefully you learned a little bit about some of the images and their technicalities, and we'll get going to some of the programs that we can use next.